In this video, we'll be looking at section 3.4. Introduction to complex numbers. Our essential question will be, how do I take the square root of a negative number? So the main idea we'll be looking at today is imaginary numbers. An imaginary number is any negative number that is under a square root symbol. Examples could be the square root of -4, -2 times the square root of -6, or 15 times the square root of -117. So anytime we have a negative under our square root symbol, we're going to end up with an imaginary number. So how we deal with this is we've created a symbol to take care of that negative. So we will say I equals the square root of -1 to help us deal with the negative under the square root. So say we are looking at the square root of -4. Well, we can write this as the square root of -1 times the square root of 4. The square root of -1, that's what becomes our I. I is equal to that, so we'll turn this into our I, times the square root of 4. So then we have I times 2, which we will write as 2I. Say we're looking at the square root of -27. Well, we know this negative is going to turn into our I. So I can kind of skip this middle piece right here and just go ahead and pop that negative out as the I. So I can say I root 27. And then I have to take then I simplify this square root. So let's say, so we can do our side work, 27, 3 and 9, 3 and 3. So I have a pair of 3, so 3 is going to pop out. So that 3 pops out, so I have 3i times the square root, and then this 3 right here goes back inside like so. Let's do one more. Say we have -2 times the square root of -54. Well, the negative on the inside is what becomes my I. So the -2 stays the same. This negative becomes my I. And now I'm just working on the square root of 54. So we'll do our side work, which I'm going to have to do over here. And I get 2 and 27. 27 breaks down to 9 and 3. And 9 breaks down to 3 and 3. So we have a pair of 3's. So now I have -2 times 3i. And then 2 times 3 goes back inside, so I have 6. So we end up with -6i root 6. So that's how we can simplify using square roots with a negative underneath the radical. Now let's look at graphing these things. I know we'll do graphing in a little bit. I want to look at some properties of I. So some properties of I are, we have I equals the square root of -1. We have I squared equals -1. We have I cubed equals negative I. And we have I to the 4th equals +1. So say I was looking for, this is properties of I. So say I was looking at I to the 7th. I could say this is I to the 4th times I cubed. I to the 4th becomes 1. I to the 3rd is -I. So I get equals -I. 1 times -I is -I. So the best way is to break this number down into as many of the 4's as possible, because those are our positive ones. And then we'll deal with whatever is left over. So say we're doing I to the 27th. Well, I'm going to write as many I to the 4ths as it takes to get close to 27. So I to the 4th times I to the 4th, that's 8 i's, times I to the 4th is 12, times I to the 4th is 16, times I to the 4th is 20, 4, 8, 12, 16, 20, times I to the 4th is 24, times I cubed is 27. So I'm just adding my exponents up to equal 27. 4 plus 4 plus 4 plus 4 plus 4 plus 4, and then 3. So that's going to equal, well, I to the fourth is 1. So I have 1 times 1 times 1 times 1 times 1 times 1. It's turning all these I to the fourths into 1, because that's what I to the fourth equals. And then we have I to the I third, which is equal to negative I. And so we get negative I. So breaking it down into the I to the fourths, and then whatever's left over, will help you use these properties of I. The next thing I want to look at is complex numbers. And complex numbers are when we have a combination of real numbers and imaginary numbers. So a complex number is written like this: a plus bi. A is the real value, b is the imaginary value. So we could have something like 4 plus 5i. Or we could have something like negative 2 minus 3i. And we can graph these. And the way we graph these is we draw a real imaginary plane. So x is the real, and the y is the imaginary. So how I would graph this is I would say, well, my real part is 4, and my imaginary is 5. So I'm really graphing the point 4, comma 5. So I go over 4, 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. So that point will be up here. So we're graphing the real, comma, the imaginary. So what would this point be? Well, the real would be negative 2. Comma, and the imaginary would be negative 3. So I'd go real, negative 2, imaginary, negative 3, and I put my point. Okay. Now using this complex numbers idea, we can solve these square root problems. So say we had the equation x plus 3 plus 8 equals 6. X plus 3 squared plus 8 equals 6. So the first thing we'll do is subtract 8. I'll bring down my x plus 3 squared equals 6 minus 8 is negative 2. Now I take the square root of both sides. And we get our x plus 3 equals plus or minus the square root of negative 2. And we'll subtract 3. And now we have x equals negative 3 plus or minus the square root of negative 2. Now I don't want to write it as a negative underneath my radical, so that's when the I pops out. And then we're done. Like that. So that's how we can solve quadratics using complex numbers. Now we see that our real piece is -3, and my imaginary piece would be the square root of 2. So thank you very much for watching this video, and I hope you have a great rest of your day.